notes, there's some you try it example problems of exponential equations that we're asking you to solve. For the first one, you have 30 times, and then the 1.025 to the x up in the exponent, makes it an exponential function, equals 90, or exponential equation rather. We want to solve for x. So we need to get this by itself first, to get the x by itself as much as possible. So the first thing that needs to move is the number 30. And to move it, it's hooked by multiplication. So we undo multiplication with division. Divide both sides by 30. 30 divided by 30 is 1, so it's 1 times, or just 1.025 to the x, equals 3. Now we're done with division because that x is not hooked to the 1.025 by multiplication. That's an exponent. So the only thing that can cancel out an exponent is a logarithm. So we're going to start with log. When you start with a log, you've got to figure out the base. And the hint is the base of the exponent is the base of the logarithm. So 1.025 of 3 equals the power. Logarithms always equal the power on the other side, or the exponent. So that's an exact answer, but we want a decimal approximation. Some of your calculators have the capability of typing in logarithms to different bases. You'd need to check your calculator, look under the math menu to see if you can do that. Some of the older models of calculators, the graphing ones, can't. So this is where we're going to do change of base, use that formula, and I'm going to use the natural log over the natural log. But remember, I could also use log base 10 over log base 10. The number in the argument, or the number on top, stays on top. The base goes to the bottom. And then you can go ahead and use your calculator to compute that out. So if I use the natural log of 3, close out your parenthesis, divided by the natural log of 1.025, again, close out your parenthesis, we come up with 44 point and a whole bunch of decimals. And in this case, it says to give an exact answer, which is what we did here, and then round your decimal answer to 3 places. So 1, 2, 3, I end at the 1, but I look to the next digit, which is a 5, which means I round the 1 up. So that's 44.492. Is my decimal approximation. My exact answer, I could either give this, or I could give this as an exact. Both of them are exact answers. For part B, I have 1.08 equals e to the x. Right? My exponential is by itself. There's nothing being added or multiplied to this. So I'm down to, I need to get rid of the exponential by using logarithms. So it's going to start with log, base, and then the base of the exponent is e of 1.08 equals the power. Now log base e, remember, we've defined as the natural log. That's my exact answer right there. For my decimal approximation, the minute I touch my calculator, that becomes my decimal approximation. So I would go in and type in natural log of 1.08 and then round to 3 decimal places. So look to the third and then go 1 more, that's a 9, so the 6 bumps up to a 7. So the approximation is 0.077. That is approximately what my x is equal to. For part C, I have 10 times 0.5 raised to the 3x power equals 90. And again, notice my variable is up in an exponent, which means somewhere in this problem I'm going to be taking a logarithm to figure out what x is. Before I do that, though, I need to get the exponent by itself. So the 10, we've got to figure out a way for it to move. It's hooked to the exponent or exponential by multiplication. So to unhook it again, we're going to divide it off. 10 divided by 10 is 1, so it just cancels out to 1. And then 90 divided by 10 is 9. Again, I can't divide by 0.5 because the x is not hooked by multiplication to the 0.5, so now I have to use logarithms. Exponents and logarithms cancel each other out. So I have log base. I look at my exponent and look for its base. That becomes the base of my logarithm. So it's a 0.5 of 9 equals the power. I can do a couple of things. I can go ahead and figure out what this is first. So again, I'm going to do my change of base. Natural log of 9 divided by natural log of 0.5. Figure out the decimal there. I'm touching my calculator, which means I'm now getting a decimal approximation. Now I'm going to come back here and get my exact value in a moment, but my decimal approximation, I'm going to again leave all those digits on the screen, but only write down a couple here so that my instructor knows what the heck I'm talking about. This is negative 3.16992, I believe. A bunch of other digits behind it. And then solve for x, so I would divide that by 3. Now the reason for leaving it on my calculator is because all I have to do is say divided by. It's going to take that answer from above and divide by 3. So the approximation is negative 1.057 because I have to round up. That's my approximation. Let's go back here to get the exact value of x. I only needed to do one more step here. Notice how I had log base 0.5 of 9 equals 3x. If I want to solve for x, I'm just going to divide both sides by 3. And that's the exact value right there. So log base 0.5 of 9 divided by 3 is the exact value. And my decimal approximation, when I started to pick up my calculator and do all that, that's my decimal approximation right there. For part D, this one is 3 plus e to the x minus 2 equals 12.5. Again, an exponential, ultimately going to need a logarithm in the problem to solve for x, but before I do that, I've got to clear away everything around that exponential. So the 3 in this case has to go, but notice now it's not being multiplied times the exponential, so I'm not going to divide it off. In this case, it's a positive 3, so I'm going to subtract 3 from both sides. So that cancels out to 0. End up with 9.5 on the other side. Now that I have it by itself, I can go ahead and get rid of the exponential by taking a logarithm and rewriting it. Log base e, I'll take care of that in a minute, of 9.5 equals the power. Another name for log base e, remember, is natural log. Now, before I take care of this using my calculator, let's go ahead and get the exact value of this one first. I'm going to add 2 to both sides of the equation. Now be careful, because you don't add the 2 to the 9.5 because that's the natural log of 9.5 and then plus 2. You can't add the number inside the logarithm. The best we can do is just leave it like this. And that's our exact value. Now you can go ahead and take your calculator and plug in the information, natural log of 9.5, close the parenthesis, and then plus 2. And come up with about 4.251. Taking a peek at the next number is 2, so we're going to just stick